Okay, so for 7.2, we are using the converse of the Pythagorean theorem. Let me take a picture. Make sure you have this written in your notebook. Okay, so we learned last time that a squared plus b squared equals c squared. The converse is just saying if I know what c squared is, and I know that it equals a squared plus b squared, then I know that this is a right triangle. Because earlier, let's see, oh, whoo, that's terrible. Let me see if I have a... Can I make a shape? Okay, anyhow. So we had a triangle. This was the Pythagorean theorem. And we knew that this was a right angle. So that's how we knew that a squared plus b squared equals c squared. So what the converse is saying, that is, if I have a triangle, and I can prove that a squared plus b squared equals c squared, then I know this is a right triangle. So that's what it's talking about. Beforehand, we knew it was. Now we're proving it is. That's.
So converse basically the opposite.
Yeah, it's going to ask you whether the triangle shown is a right triangle or not. Okay. And you do the Pythagorean theorem to say yes or no.
Okay.
So let's go to example 1. I'm surprised I can't draw a shape with this thing. I don't have any more shapes. Hey, it kind of worked. All right, we're going to go with that. Okay, so we know that this is 9, this is 3 square root of 24, and this is 15. Okay, and they're asking you whether this is a right triangle or not. It kind of looks like it could be, but not 100% sure. So we're going to say, we're going to use Pythagorean. So a squared plus b squared equals c squared. And we're just going to plug everything in. So we have 9 squared plus 15 squared equals the 3 square root of 24 and all of that squared. So that's how you would write that. Thank you. See, I'm having a day. 34. There we go. So this should be 34 too. All right, so now we're going to square everything. So the first thing is, when you have this whole thing in the square, you can apply this square to the 3 and to the 34. So what's 9? Let's start on the left. What's 9 squared?
81.
What's 15 squared?
225.
Okay, and then 3 squared. And the square, when you have the square root of anything that has been squared, it cancels the square root and it just becomes 34. So then all you have left to do is, what is this 3 squared?
9.
So then I have 81 plus 225 on the left. And then I have 9 times 34 on the right. So now we just simplify. What's 81 plus 225? 306. And then what's 9 times 34?
306.
So does 306 equal 306? Yes. So then yes, this is a right triangle. And that's the gist of it. Make sense?
Yeah.
All right, let's do another one. Now, if you ever come out with this value being a different value, then you would say, no, it's not a right triangle, which I'm assuming is going to be our next example. So let's do B.
So usually the largest number, like, for example, on B it says 22, 14, and 26. 26 is usually C?
Yes. Yep, that's a good way to think of it. Where's my shapes? I had figured out how to do a shape. All right. So we have, yes, I'm getting better at this mess. So this is 22, 26, and 14. So yeah, this is going to be A, B, and C. Now I wrote how we normally write a squared plus b squared equals c squared. I wrote it that way last time. You can also write it in reverse. So I can write the 26 squared equals 22 squared plus 14 squared. As long as your a and b is on one side and your c is on the other side, it'll work. So just showing you can't write it in the different direction. All right, so what's 26 squared?
676.
Okay. What's 22 squared?
484.
And what's 14 squared?
196.
All right, so then we just need to add 484 plus 196.
680.
All right, does 676 equal 680?
No.
So no is how you say that on the equal sign, and then you would say not a right triangle. My handwriting is terrible to begin with, and then I try and write on one of these whiteboards, and that makes it so much fun. All right, any questions? All right, so real quick, look down at the guided practice so you can see how you can use your triples. Remember the triples from the last lesson?
Yeah.
So if I have 4 to square root of 3 and 8, without measuring this, without doing the math, can you look at that and see if it's a triple to see if it's a right triangle? Yeah, you have it in your journal, but you can also look on page 429. So is there one that is 4 something 8? There is not a triple that's even close to that. So the two ways you would do it is to actually solve this. So I'd say 8 squared plus equals 4 squared plus 4 square root of 3 and square that to see if it works. So 8 squared is
64.
and then 4 squared is
16.
and then we have plus, and this is 16 times 3, right?
Yeah. Mm-hmm.
What's 16 times 3?
48.
So then what's 48 plus 16?
64.
Yep. So then you'd say, yes, this is a right triangle. So you will come across where it gives you the 3 measurements like this, and you can recognize that it's a triple, and you don't have to do the solving. You can just go, oh yeah, that's a right triangle for sure. Okay, so I just wanted to show you that you can look that way. All right, so you got 2 theorems to write. I'll give you a moment to write those in your journals. All right, so these theorems, the picture's a little wonky because my book bends right there, but I'll go over them anyways. These are 2 theorems that tell you how to classify a triangle. You've seen the classification acute and obtuse. Acute meaning all of the angles are smaller than 90.
Yeah.
And all obtuse is you have at least one angle larger than 90. And most triangles you can immediately know one way or the other, but sometimes you can see here in the pictures that they're pretty close. Well, the obtuse one is obviously obtuse. But when you are using the Pythagorean theorem for an acute, you see how the hypotenuse, the c squared, will be less than the multiplication of the 2 legs, a squared plus b squared. So if I came out with my answer being 134 equals 120, then you know this is bigger. You know it's not an acute triangle. But if I came out with it saying, 108 equals 127, then you would say, okay, this one is an acute triangle. Okay? And the other is the obtuse. So this one where the c squared came out to be larger, then this is the one that's an obtuse. So that's just how you classify. If they come out to be exactly equal to each other, that's your right triangle. So now you have 3 ways you can classify them. All right, so let's go. Example 2. Can segments with the lengths of 4.3 feet, 5.2 feet, and 6.1 feet form a triangle? And if yes, would they be acute, right, or obtuse? So first you look at the triangle inequality theorem to check that the segments can make a triangle. That's where you make sure the two sides added up are less than the third side. And you do it for all three. So I would go 4 plus 3 and 5 plus 2 is what? 5.2. Add those together, you get what? 9.5. That's larger than 6.1, right? So then again, I'd look at these two. Do those two add up larger than 4.3? Yeah. And then the 4.3 and the 6.1, make sure those add up and they're greater than the other side. So that's the quick check to say, yes, the sides will actually touch. So then now we're going to use the Pythagorean theorem to decide which label we're going to give it. So we have, these are your shorter ones, so we have 4.3 squared plus 5.2 squared equals 6.1 squared. Okay, so 4.3 squared is?
18.49.
Yep, 5.2 squared is?
27.4.
Very good.
27.4.
Yep, 04. Mm-hmm. And then 6.1 squared is?
37.21.
All right, and then add the two legs and we get?
45.54.
Yep.
53.
Yep, 53. Good. So which one is greater, the legs or the hypotenuse?
The legs.
The legs. So according to our theorems, the triangle is? An acute triangle. Yep. Any questions? All right. You're not required to put the concept summary in your journal because it's everything you've gotten so far, but it would be a quick check kind of place. So if you want to put that in there. Yeah, I always put them in there. Retake. Blurry. All right, so this is just a concept summary, so that way it can help you remember what each of these theorems are. That's it. That's the lesson. Numbers 3 through 33, you may do just the odds.